Around week 4 of intrauterine life, the upper limbs begin to develop.
The process of limb development displays the transition from an upper limb bud to a fully formed upper extremity that will continue to grow until adulthood. At week 4, the upper limb buds appear on the lateral plate mesoderm, stimulated by the expression of the Hox gene family. The apical ectodermal ridge, AER, a ridge of thickened ectoderm, differentiates along the tip of the limb bud. The AER starts to secrete fibroblast growth factor 8, FGF8, which will stimulate limb elongation throughout development. The zone of polarizing activity secretes, determining the placement of the 4th and 5th digits. Additionally, the expression of the Hox gene family causes the subsequent expression of TBX5, formerly through to be a determinant of upper limb identity. The upper limb bud continues to grow and the handplate is formed. At this time, it has a shape similar to paddle. The digital rays begin to develop, giving rise to the primordial digits, which will ultimately become the digits or fingers. AER continues to secretes FGF8 at the tips of the digital rays, causing them to continue elongating. At the same time, the spaces where AER regresses the cells undergo apoptosis and sculpt the interdigital spaces. BMP2, BMP4, BMP7, and the transcription factors MSX1 and MSX2 are heavily expressed in these spaces. As the limb continues to elongate and the tissues differentiate, it rotates and adopts its anatomical position. Dermatome distribution. Dermatomes extend with the limb as it elongates. At this time, the basic structures of the upper limb have fully developed and growth continues until adulthood. Development of the lower limbs. Intrauterine lower limb embryonic development begins at around week 4, day 26. The process begins from a limb bud to the fully formed lower limb, with growth continuing till adulthood. At week 4, the lower limb buds appear on the lateral plate mesoderm, stimulated by the expression of the Hox gene family. The Hox gene family causes the subsequent expression of TBX4, through to be a determinant of lower limb identity. TBX4 activates fibroblast growth factor 10, FGF10, which in turn activates FGF8, instrumental in the formation of apical ectodermal ridge, AIR, QT, the tip of the limb bud. This is followed by expression of FGF4 and continues FGF8 expression at the AER, causing replication of the mesenchymal cells proximal to the AER, leading to limb elongation. The zone of polarizing activity secretes sonic hedgehog, SHH, determining the correct anteroposterior orientation of the limbs. The lower limb bud grows into the footplate, followed by the development of the digital rays. AER is preserved at the tip of the digital rays, while it regresses in the spaces between the digital rays. Expression of FGF8 continues at the tips of the digital rays, causing them to continue elongating. The cells in the spaces where AER regresses undergo apoptosis and form the interdigital spaces. This is influenced by BMP2, BMP4, BMP7, MSX1, MSX2. With continued limb elongation and tissue differentiation, medial rotation occurs for the final anatomical position. As the limb extends, so do the dermatomes. By the 8th week, the basic structure of the lower limbs is fully developed and growth continues until adulthood.